Hello class, I'm Winter Wu. That's the name, my name. Win. Tat. Wu. That's the name. So guess where I'm from. Guess where I'm from. My nationality. Guess my nationality.
Chinese.
Sorry?
Chinese.
Chinese. You have any idea where I'm from? Like first impression.
Singapore.
Singapore. Right? Singapore, Chinese.
Singapore Chinese.
Yeah. Actually, I'm from Burma. Have you heard of the name country called Burma? B-U-R-M-A. Burma. That's what we used to call the country in old times.
I think that is the old name
Yes,
Burma.
that is the old
Now
name.
it's Myanmar
Yes,
already.
right.
Yeah, those living in Myanmar are Burmese.
Yes. True, right. So this originally I come from Myanmar. And Singapore, I did study in Singapore for like 3 years. I got my first diploma in business administration there. I completed in like 2012. Yeah. So some say I look like Singaporean. You know, some say I look like Chinese. Yeah, some say I look like Burmese. Some even say I'm from Thailand. So I'm here only for like 2 weeks. And I'm learning Thai words a little bit. I know the words like Yendi Tita Ruja, right? Is that how you pronounce it? Yendi Tita Ruja. Nice to meet you.
Nice to meet you.
Yeah, Yendi Tita Ruja. And something like I don't know in what's like Home do or something like that. I'm learning Thai. So I'm from Winter. I'm Wu. I'm from Myanmar. So let's introduce each other. Start with you. Where are you from? Can you stand up, please, and face the classmates? Just introduce yourself. Where you come from?
My name is Elias Per Iturino. Just call me Eli. And I am 24 years of age, and I came from the Philippines.
Philippines. Wow.
Thank you.
And how do you greet in Philippines? Hello in Philippines.
Kamusta?
Kamusta.
We call it kamusta, or in because we are the same. I came here just last 2 weeks, and then I don't know much Thailand, so that's why a local language. Yes.
Yeah.
That's why I'm having a hard time to communicate in locals. That's why I communicate with English, but some they need to practice yes more.
Yes. Kamusta.
Kamusta?
Kamusta, everyone. And how do you say thank you in Philippines?
Salamat.
Salama. Can you repeat that word? That's the last
Kamusta.
one. Kamusta.
Salamat.
Salama. Wow, very nice. Okay, you can sit.
Thank you.
And you? Where are you from?
Hello class, my name is Kanjita, you can call me Kai, and I'm from Myanmar, and I have been like 4 months already here. Thank you, nice to meet you.
And how do you say hello in Burmese?
Mingalawa.
That's here.
Mingalawa.
Mingalawa. Can you repeat it?
Mingalawa.
Mingalawa. Now we're learning, right? Mingalawa. And how else say thank you in Burmese?
Jesu Jamai.
Chezu Temai.
Jesu Timai.
Oh, very good. Okay, you can sit. So, can you introduce?
I am from Philippines. I am Juan Gonzalez.
Oh, you're also from Philippines?
Yes.
Wow.
I've been here 7 years
Wow, 7 years.
already.
Nice. Have you done Thai recently?
Thai?
Thai words?
Yeah. Sawadika.
Sawadika.
Hello. Then Kapunka. Thank
Kapunka.
you. Then when you want to point something, ani. Taureka, how much?
Yeah. Or like how? Right.
Yes.
Oh, good.
Kapunka.
Kapunka.
Thank you.
How about you?
My name is Anna. I'm from Thailand.
Anna from Thailand. Wow. Rindi Tita Ruja.
Nice to meet you.
Okay, let's start class. So as you all know, I will be teaching chemistry here. So kids, what do you know about the chemistry? Speaking of chemistry, what do you know? Okay, before I teach, I need to ask this question. Do you love science?
Yes, I'm a science major too.
Wow. And any of you? Do you love science?
Yeah.
What do you love about science?
Study of life, study of everything, the universe,
Yeah.
chemicals, everything.
Yes. Anyone else? What do you love about science? When you heard about science, is it like,
New discoveries.
yeah. Do you love science?
Yes.
In what major? What do you prefer?
I am more on philosophical aspect of the science,
Oh, I see.
like metaphysics.
Yes, yes.
That's what we studied during college.
Wow.
So we are talking about the cosmos. It's a bit hard to explain, but it's like that.
Yes, yes. Wow. How about you?
The only reason that I love science is we cannot learn a lot from our daily life,
Yeah.
and it also really changing somehow. So.
Yes. Every day we go, everywhere we go, we touch science, science everywhere around us. So we must know the science. We cannot avoid science. Yeah. So in science is like the scientific way that people call everyone says like scientific way. What is the meaning of scientific way? It needs to be proven right. Like why it happens, how it happens, when it happens, like that. We need to have the facts. We need to prove every fact right. That is the science. That's the way of scientific. That's the way of science. That's what we call scientific way. All right. So what, when, how, and why. All right. And we people always say like, you and me have the same chemistry. What does that mean? Have you heard the word chemistry where we use? You and me have the same chemistry. You can do that, like that.
Getting along with.
Yes, getting along with. That means one reaction, one substance, we react, we get along with. Like a coffee powder and the hot water, it becomes a coffee, like that. You have the same chemistry, man, we get along with. Yeah. So it's like the standard walk for chemistry. Is what we use. Okay. And I have a question. In real classroom, would you provide the projector, the screen?
Yes.
Yeah.
In real school they have. Yes,
Oh.
they have projector. Yes.
Yeah. Okay. So since we don't have the projector here, I'll write it.
They have.
Yeah. Okay. All right. So usually there are 5 traditional branches of chemistry. All right. You can see in the textbook too. 5 traditional branches of chemistry. I mean, there are billions of branches in chemistry, like industrial chemistry, like biochemistry, physical chemistry, something like that. There are many subjects under the name of the chemistry. But usually we talk about the 5 traditional branches of chemistry, which is inorganic chemistry. And what is the opposite of inorganic? The opposite of inorganic. Organic chemistry.
Organic.
Right? And analytical and physical and biochemistry. Kids, science class supposed to be fun and feel free. Don't feel stressed. If you ever have any questions regarding what I'm teaching, feel free to ask me. All right? Okay. So what is inorganic chemistry? If you know the meaning of organic, you can talk about inorganic. Right? So can you show one example of inorganic chemistry? Inorganic. Come on, you can do it. It's very hard. It's okay.
Dynamic subject.
Sorry?
Dynamic things.
Yes.
Dynamic things.
Yes. Okay. Can all of you come here for what? and I can teach you with the graph and the. Can you see?
Yeah.
Can you come forward, please? So move your chair here. If you can come in and sit. All right, this is organic and inorganic. Can you see?
Yes.
All right. I think this. Okay. Now you see what is organic and inorganic. Organic like DNA. The meaning of DNA. Do you know the meaning of DNA? Okay, let's search on Google, right? What is the meaning of DNA? Let's find out what is the meaning of DNA. All right. Hey Google. What is the meaning of DNA?
Inorganic chemistry is lack of hydrogen.
Yes.
It's a lack of hydrogen. The inorganic chemistry. Hydrogen, carbon hydrogen.
Carbon hydrogen.
Yeah, it's a lack of carbon hydrogen. While the organic chemistry has the carbon nitrogen.
Yeah. You do you have any idea of the meaning of DNA?
No, I don't have idea.
Okay. So why don't we search all together on Google? You know, the way of teaching, we need to use Google and we get more lessons, more knowledge. Alright, maybe you can ask, hey Google, can you explain more meaning of DNA? Sorry. Hey Google, search DNA meaning. I use my
DNA.
oh, the Wi-Fi is not connected, so it's okay. Right, so basically what I'm saying is organic chemistry means we are studying the things in living things. We are studying the living things in organic. That
Okay, thank you.
others, everything is chemistry. Inorganic means it does not have the living organism. So it's called inorganic. Alright? So these are the examples of organic and inorganic chemistry.
I will interview you online, okay?
Inorganic chemistry is like table salt, carbon dioxide, diamond, silver. It does not have the living things inside. It does not live. But every living thing's organism that in the chemistry is called organic chemistry. So now we all know organic and inorganic, right? Do you have any questions about organic and inorganic chemistry? Any questions? No? Okay. And analytical chemistry. Analytical chemistry is like, we record every chemical reaction, every experiment, and we put it in the data like that. Like for example, oxygen, how much oxygen containing, like carbon dioxide containing, like that. That's called analytical chemistry.
Yes.
Okay, that is called analytical chemistry. Everything we record from the experiment, we put it in the table like that, or maybe like a Excel sheet or something like that, put in the report systematically. That's what we call analytical chemistry. For example, when we use analytical chemistry in a hospital, in experiment, in science projects, like that, we need to put every report so that we can adjust which one is more higher, which one is lower, which one will be dangerous when it reacts, something like that. Alright? So that's analytical chemistry. And alright, physical chemistry. Physical chemistry is like physics plus chemistry. It's what we call physics chemistry. Right? What do we know about physics? Gravity, center of gravity, mass, and any others, like anything you know about chemistry. Physics. Anything you know of physics? Just prove one example. Just tell me one example of physics. Like one word of physics. It's okay. You can search on Google. You can tell me.
Physics is the natural science that studies matters,
Yes.
the motion and the behavior of space, time,
Yes.
the energy and the force.
The energy of the force. Right. Is physics interesting?
Yes.
Yes, interesting, right? But it's sometimes very hard when we do the calculation because we need to know the theory and we need to apply it. Most students they know the physics theory, but they don't know how to apply in the calculation. So they might end up hating physics. Like that. So physics is also important in our daily lives. We use it in mechanical things, transportation, and like infrastructure, building infrastructure, construction is where we all need all physics. So we need to have the basic knowledge of physics too, right? Now we are talking about physics, chemistry. It's more like a little bit complicated, two words, physics and chemistry. When combined, it becomes physics, chemistry. So what are the things of physics, chemistry? I will show you. The mechanism, right? Any of you have any questions I'm teaching so far? If you have any question, feel free to ask me. You can use it Google on your phone, search anywhere you like. It gives you more knowledge, maybe more knowledge than what I'm telling. What I'm teaching. That's the way of using the internet, right? Because in today's teaching, we need to have the internet access. For example, like you want to know something like this coffee today. What this coffee, which company come from, what country made this coffee. So we search it on Google, and we find out what the chemical compounds included. Is it good for health? Is it good for a long time, drink, something like that? That's how we use internet, alright? Some people use internet wrongly today, like they only do like social media posts, getting the like flags like expensive things on internet. That's not the way we should use internet. The way we should use internet, we need to find what we want to know on internet, on Google. Just type one word, it will give you all examples, all solutions. So that's the way of using internet, right? Okay? So physical chemistry is the study of mechanism. It's also the rate, the rate and the energy transfer that happens when matter undergoes change. Like how the energies react. That's the way of learning physical chemistry. And study interaction between two elements. And study of properties and changes of matter and energy. These are physical chemistry. I know it's complicated what the physical chemistry that is more similar to physics, so you don't have to be afraid of the word physical chemistry, right? And biochemistry. So biochemistry is the same, like similar to the meaning of physical chemistry. It's biology and chemistry, right? Biology is study of our living things, like animals, human, life, true. So in biochemistry basically means what is happening in the biology, the living things, like what are the chemical compounds contain, the amount of the chemical compound reaction, something like that. And we just learn it, study it, we record it, and we just state the facts. That's the learning of the way of learning biochemistry. For example, we eat something, maybe like it's very big food, like a chicken breast like it's very big. We eat and we're very full, and we cannot even walk. It's very heavy. Our stomach is very cannot walk. And when we sit down, and we think about not going anywhere, just sitting like for 1 hour, 2 hours. Do you know what happened? Do you know why it happens when we eat the big chicken breast like? And why can't we walk? So we learn. How do we learn? We learn first biology. What are the human bodies made of? Like the vessels, blood, and stomach, you know. And there's acid in our stomach. Acid is contained in our stomach. You can search it on Google. So when we eat something, our stomach does not just digest. The acid in our stomach digests the food. So it becomes, then after that we go try that. Alright? That's the way of digestible. So speaking of the biochemistry, we learn how the acid reacts the food and how it digests like that. What are the amount of acids and what the acids do like that. That is the biochemistry. Alright? Do you have any questions for biochemistry?
No.
Okay. So shall I continue? Okay.
Yes.
So in science, we must have these facts. What, why, how, when. We need to prove everything right. Just as I said earlier. Why it happens, when it happened, how it happened. So like that. We just don't prove like just don't like that. Okay, for example, here's water. What water is made of? We just can't say what is made out of water, right? We need to prove it right.
Made of hydrogen and oxygen.
Yes, hydrogen and oxygen. So it becomes H2O like that. We need to prove it right. What are the real substance in the water? Like what are the hydrogen? What is oxygen? What is oxygen made of? Like that. We need to explain more. You know, science should be fun and interesting. It's not like not listening to what teacher says all day in school and go back and this is boring. There's no meaning of you know.
I think teacher one oxygen is only oxygen, not two.
Oxygen is called O2.
Because I know that hydrogen is only two, the oxygen is one atom. One.
Right.
It's only H2 plus 0.
Oh yeah, maybe I might be wrong. I need to check. Okay, sorry about that. It's okay. We are learning each other. So when we do mistake, we find mistake and we learn it together. That's the way of learning, right? Okay, good. Let's check. Oxygen compound.
Teacher, maybe you can continue and we have to check later.
Yeah, sure. Alright, yeah. Maybe oxygen is right. Just O. My bad, I'm sorry. So, but thank you for correcting my mistake. That's the way of learning in the 21st century. Alright? Alright, okay. So the father of the chemistry, you know, who founded the real chemistry? That's what we call. He's from French. His name is Antoine Lavoisier. Right? Let's pronounce the word Antoine
Lavoisier.
Antoine Lavoisier. He's the father of the chemistry.
He's French.
Yeah, he's French. He founded the chemistry and he designed equipment. He used observation. That's the way of the chemist. See, he used observation. He used the equipment. He designed the equipment. He also measured the experiment like that, and he discovered also nitrogen. Right? Nitrogen. We always heard the word nitrogen, right? Where do we use nitrogen? Speaking of nitrogen, where do we use nitrogen? Nitrogen. Basically, you can see it on fish, you know.
Chemical elements with the symbol M.
Yeah. Acorn.
It's atomic.
Also, what nitrogen do? In fish, it preserves the food longer. You know, without nitrogen in the fish, the food will be rotten. So we need to use nitrogen. We use nitrogen in the fish and acorn also. There's the air conditioning. When the gas ran out, we don't feel cold no more. So we have to fill up the nitrogen gas in the aircon too. So that's why we use nitrogen. That nitrogen gas is founded by the father of chemistry, who is Antoine Lavoisier. Right. And he also discovered law of conservation. All right. Law of conservation. Alright, I'm going to give you one example about law of conservation. Have you seen the word charcoal? Have you ever heard of the word charcoal? The color is black, it's made of substances, you know. When you touch, you can feel black powder like that. So basically, in old time, we use charcoal, you know, for trains, from going from one place to another. And we also use it in cooking food. You know, now we use the nitrogen, what was it called? The LPG, no, not LPG gas. The gas that we use in house when we cooking, what was it called, the gas?
Stove.
Yes, the name of the gas.
Stove.
The name of the gas is LPG.
Butane.
I think liquid petroleum gas, LPG.
LPG.
Yes, yeah. Liquid petroleum gas. When we don't have the liquid petroleum gas, let's say, suppose we run out of the liquid petroleum gas in our town, and we need to cook food, right? We need to eat. Otherwise, we'll be dead. So, without LPG, how can we cook the food? We use charcoal. All right, charcoal. We burn the charcoal. We ignite charcoal, and the charcoal maintain the fire longer. It means it burns much longer than other substances. So that's why we use the charcoal when we cook the food. So
Sometimes we use firewood.
yeah, firewood. But charcoal in Myanmar, most people use charcoal. Yeah, because we don't have much liquid petroleum gas. It's like that. So we use charcoal when we cook food. All right. So talking about law of conservation, right? When we burn the charcoal, let's suppose this is the solid state, the charcoal. We burn, and it becomes powder like that. All right. Imagine this is powder. We burn the charcoal and it becomes a powder. So even if it in powder state, you know, the law of the mass. The mass does not change. The amount of mass in charcoal, in the carbon, the amount of the carbon mass does not change even in this mixture state, the powder state. That's what we call law of conservation. Even if it reacts, even if it changes to the mixture powder state, the mass does not change. That's what we call law of conservation. All right? Like that. All right. So as I said, the scientific method, we must have let's say here, there's a coffee. So before we do the coffee, make an experiment, we need to record the things. Like what is a coffee, like that. I'm gonna give you one example, like how we do the coffee. So here's coffee powder. Here's hot water, what we have. All right. So when water mixed with the coffee powder, it becomes coffee. What is coffee? Coffee is basically liquid, right? All right, liquid. And what color is coffee? Maybe black. Yeah. Some say coffee color, brown, whatever. Okay. Like those kind of record the things. It's the way of science. It's the way of science, the scientific way. That's what we call. All right, hot water, coffee powder, like that.
Sugar.
Yeah, sugar. If you want to add sugar is fine.
Honey.
Yeah, honey. Like that. Then it becomes a coffee. So what are the
Creamer.
Sorry?
Creamer.
Yeah, creamer. Nice. How do you like your coffee? With creamer or
With chocolate.
with chocolate? Yeah, I also
milk.
like. Yeah.
Milk.
Me too. I also like hot chocolate. It's
Seems like Starbucks.
yeah, Starbucks, same like Starbucks. So speaking of chocolate, chocolate reduces stress. Like in daily life, we have much stress, like daily
Energy.
Yeah, it gives energy, chocolate. So we learn about chocolate in our human body. So it's what we call biochemistry. I'm giving